Hello again, everyone, and welcome to Enterprise Linux Security episode 73, where we have identified at least 4,500 web managers and web admins that are not listening to this podcast. We'll explain that later. How you doing, Zhao?
All good. As always, a pleasure. Yeah, that's one way to put it. We actually are going to cover two stories today. We're going to be looking at some information that is exposed in the web when it shouldn't be, and we're going to be looking at the revision of the vulnerability scoring system, which sounds very dull and dry, but bear with us, the system is utterly broken.
Yeah, so that'll be the entertaining part, right? Where it's just like, it's broken. Let's talk about why it's broken and what's needed to make it not so broken.
Now, we're actually going to cover the changes that are coming with CVSS 4.0 and why it's different from 3.1. And we're actually going to be talking about some examples of things that went wrong with 3.1 and the scoring of specific vulnerabilities that has actually led to this revision, and we likely won't end at version 4.0, but we'll get to that. The first story that we have is related to exposed information on websites. So there's this company called Truffle Security. I actually had never heard of them before reading this story. And they have a program, and I kid you not, it's called TruffleHog.
Yeah.
So weird naming aside, this is basically a piece of software that will look for secrets and credentials and all of that across your infrastructure. It all looks very nice. Look them up if you're interested in that. But they announced that they had run a test against Alexa's top 1 million websites on the internet. And they were specifically looking for the directory immediately at the top level of those websites called .git. So if you're into development, if you're into sysadmin stuff, DevOps and all that, you know what this means.
Yep.
The websites were being developed, they were under source control under Git, and there is some automation tool here in the middle that is pulling the websites from the repositories and publishing them live. Sounds good?
Yep. Yeah.
Sounds
well,
good so
and
far?
I'll also mention, yeah, it does kind of. If it would be much better if those folders weren't leaked. So for anyone that is maybe new to any of the industries that we've mentioned, when you have a Git repository, GIT, but I probably didn't need to say that, like get off my lawn, basically. I think that's what something like that. Linus made it. Anyway, popular version control system, the .git folder is in every Git repository, and it contains all the metadata and transactions and histories of your repository. And there's also a config file inside there as well that you have your submodules, which are other repositories that might come along for the ride that you could pull in, like if you have other libraries, for example. So it has a wealth of information. And if you can get into that folder, you can effectively poison the local copy of the Git repository. And if the credentials are there, which, we'll talk about that, you could, cause malware to enter into those directories. And that's basically what we have here. And that's what they found when they scanned, like you said, the 1 million websites, or the top 1 million.
So let's get the advices out of the way immediately, because this is something important that you should be checking. So if you're running any websites or something like that, and you have continuous delivery, continuous integration in place, and you have some automation in place for your developers to publish, check your .htaccess files to make sure that you're excluding .git from publishing so that it's not accessible. That's the easy way to restrict access to it. Apache will respect that. Just make sure that .git is there and that people cannot access that directory or anything under it. So why? Sorry.
Oh, go ahead.
So why is this important? As you just mentioned, that folder contains a config file and contains the log and the transactions and all of that. And something that some people might not realize is that your credentials are also stored there when you use certain tools. Say stuff like your GitHub tokens, for example, or AWS tokens, or your username and credentials for other services. All of those will get saved somewhere because they are used in the continuous delivery pipeline. So the usual place where that lands is inside that folder. Sorry, that directory. Folder is from a different system. Directory. I know people are fuming already. So it's inside that directory. So that should be excluded. What these guys found when they ran this scan was that this amount of websites, 4,500, which in the grand scheme of things is not that much, to be honest. They scanned 1 million, they got 4,500 results. It's not that much, but it's still a significant amount of websites that are leaving this open.
Yep.
And they discovered that there are credentials inside of it, there are tokens inside of it, they are valid, and they tried to use them, and they could. One of the things that they found was that the accounts that were being used for the continuous integration and delivery and the publication and all of that actually had more access than they needed to have. They could not only read from the repositories where they were pulling the code from, but they also had basically the default settings. So they could also write to those repositories. So if you're in that situation where you have that workflow in place, make sure that the accounts that you're using can only read in this situation. If you have an account that is used just for publishing, make sure that it can only read from the repo.
Yep. And to piggyback off of your advice here, if you create a .ht access file, which you mentioned that Apache will respect, and you add that .git folder to it, don't just assume you're done. Try to access it yourself, because you could, with version control, you could easily get into a situation where you've added the file, maybe you didn't commit it or something, or it's not taking effect in some way or another. But just try to get into that folder. And while you're at it, just look at some of the other directories in the root of your web root. Like, just do an ls command. You have a list of directories there. Just start trying to traverse directories locally. Obviously, you don't want to trip any intrusion detection systems, which you could easily do by trying this. But just make sure also your network admin and managers know you're doing this. Otherwise, it could look like really, really bad. But the point is, you add the folders, directories to that file, to the htaccess file. Almost started creating some fumes of my own here, like people upset with me. I do the same thing. But just make sure that you truly can't access those folders directories. Gosh darn it. Make sure you can access them, and just give it a shot. Make sure the right people know. Don't just assume that you fixed it. Anytime you apply a fix, even if it's some other thing, you always have to make sure that you test it to make sure that fix is something that's actually fixing the problem. Because in IT, it's so easy to think you did it the right way just to find out some nuance creates a problem that still makes it open. So these are things I feel like web developers and system administrators should be doing anyway. And we have 4,500 websites that are, I guess, maintained by people not listening to our podcast.
Probably. The thing is, people are rightfully so adopting continuous integration, continuous delivery, all that stuff, that fancy DevOps stuff. But they are doing it, again, following best practices and not actually understanding the security concerns behind this.
Yep.
When you have your scripts in place, when you have your deployment pipeline in place, you might actually want to make sure that your scripts are actually handling the cleanup stage. So you deploy stuff and then you eliminate the stuff that doesn't need to be there. Or you actually only pull the stuff that needs to be there, so that at no point is the other stuff in the actual website. But that phase, that cleanup phase, that making sure that nothing is leaking phase, there are also tools that can help you with that, like the one that these guys used, for example. But it should become second nature. You're not just preparing scripts to make the deployment, you're also making sure that the deployment is secure when it's done. And that should be a priority when you're implementing something like this, which was obviously not the case here. Another thing that's interesting, and we have talked about tokens specifically on a past episode. One of the reasons why people use tokens is that they are very easy to expire, for example. Oh, somebody mishandled the token, let me expire and problem solved. Nobody can reuse it again. But that means that at some point you need to be aware that it was out in the open. If it was found through a scan like this, you have no indication of it. So you don't know that you need to expire the tokens that were accessed. While tokens are a good security measure and are a good practice for most of these online services, you should still make sure that they are not leaked. Just because you have the ability to easily expire them without going through all the hassles that, say, password recovery has, or creating new accounts or all of that. You just expire a token, create a new one, replace it, and you're done. you should still make the effort to not leak these tokens. Just because they're easy to manage, they are not that disposable.
Exactly. And another thing that I often see too, it's somewhat related here, where you could have I think it was .aws was the directory under the home directory for Amazon Web Services, where you have a token in there. Obviously, you want to lock that down and make sure that that's not in version control, because I've seen, and you've seen, obviously, people literally putting tokens in version control on purpose because they want to make it easy, and they're making it easy for the wrong people. But just keep in mind, if you have any kind of token, what is going to happen if someone else gets a hold of it, which is, they're going to be able to do everything that you're able to do with that same token.
And as Jackson mentioned in the chat here, the HT access is a band-aid in this case. The real solution to this is not putting the folder the directory there again in the first place. Damn it, right. This is contagious.
Yep.
So the HT access, it can have that protection. You should have that protection, but again, in the first place, you should avoid having that folder there. And I said it again. Man, this is really nasty.
Yeah, it's really hard because we being a system administrator, you're working on different. Yeah, well, you work with different operating systems, and there's different correct terms for different things. So, for someone who understands every environment, or the majority of them at least, it's like we get that problem where we just use terms for one platform on another, and I catch myself doing that in my videos like constantly. So
yeah, problems of doing something like this live.
Right.
But yeah, the real thing behind the story is that you never know what people will be looking for. So all of the delivery pipelines that you set up, all of the automation tools that you set up, they have a security risk attached to them. There's an attack vector attached to them. And you should always make sure that you're operating under the safest way possible. And that means taking care of your credentials, taking care of the secrets, taking care of something else that these guys also mentioned, and I was almost forgetting to mention, was that the credentials that they found there were also used in API endpoints on different services. So they were basically reusing the same accounts for different things. Please avoid that. If you're using automation, you can easily specify different accounts for different purposes, so you should avoid reusing accounts for this. If one leaks, then everything leaks. So having different accounts at least would reduce the exposure surface there. But yeah, just keep in mind that your pipeline needs to be checked to make sure that you're not putting out there too much information. And this is also something, and this is tangentially related, that is easily found in repositories that are published to, say, GitHub, for example. GitHub actually has a facility in place that will alert you when they spot tokens that are published publicly, and you will get some alerts if they detect that in the code that you're submitting. But that happens post-fact, so it has already been uploaded, the system has already seen it. So in the first place, the right measure is avoiding uploading those tokens there. It's not easy to do. It's very easy to mishandle this and to actually let something slip, but it's something that should go in your checklist before you upload stuff.
Yeah, and these are things I feel like DevOps people will run into, is how to use a token while also preventing it from being used by someone else. So one way, of course, is to have it in your home directory. That's, obviously make sure that there's no read access to other or group or anything, and it's just you. And you could put it in that directory, and there's environment variables when you're, doing whatever you're doing that could load it into memory and keep it out of that folder directory. Gosh, this is going to be a meme at this point on this podcast, I think. But that's usually the best way to do it. And there's other workarounds too, because if you're using Ansible and you're deploying a site, you could have it download the entirety of the Git repository into a directory. I did it. That is not in your web root. That is not in a place that anyone has access to. Delete the Git folder. I'm talking about on the target, and then move the folder where it needs to go. And you could have a chain like that. And if you're just going to purge the repository and download it fresh every time, which is always what I do, I forgot the argument you give Git, but you could literally tell it, ignore anything that's changed. And if something's changed, just blow it all away and just make sure the latest version is the only thing there. So that's something we could probably talk about in more detail in a future episode of, ways of avoiding this kind of thing. But in the meantime, I think the takeaway is be very careful what's within reach of your web server.
And this is actually a security concern that's very similar to something that we've been dealing with in Linux for many years now, which is properly securing configuration files. All the stuff under etc, for example, all of those configuration files there, they should have specific permissions that don't let regular users read or modify those files. Only the services that need to access them should have the right permissions to do so. And this is something similar. It's very easy to mishandle those permissions, to give it too much access, or to change the owners in the wrong way, or the group in the wrong way, and then users that shouldn't have access to the files do have. And this is the same type of thing. It's not applying the correct practices, the correct permissions to stuff, and in this case, uploading the wrong stuff to the wrong place, basically.
Yep. If it's making it super easy, just make sure it's not easy for someone else that shouldn't have access, because that's exactly what will happen if they do have access. It'll be easy to do whatever the heck they want.
Okay, let's move on to our second story of today. There is a revision to CVSS. This is the Common Vulnerability Scoring System, and you're going to be seeing CVSS 4.0 come up at the end of October. There is a period where they are still accepting suggestions and comments on the proposed regulation for this until the end of September. We will have the links for this, but the idea here is to address some of the problems that are happening with CVSS at the time. The main problem is that it's highly subjective. The way that the scoring is done for specific vulnerabilities is sometimes weird, and let's keep it at that. I'll give you an example of something that happened on the 23rd, 25th of August, just a couple of weeks ago. There was a vulnerability that was requested and received the CV number, and it got the scoring and all of that for curl. I really like the project. I came back to curl as an example because it's used everywhere. It's one of those tools that you always have handy. It's really helpful for many different protocols, and yeah, it's definitely go-to. So what was this vulnerability about? Curl has this command line parameter, or this option if you're using libcurl, where you can specify the delay between retries for a given request. You ask him to do a request or to do an upload or something like that, and if it fails, it can retry after a given period of time, and you can specify that delay. It turns out that if you pass it a large enough value, it will actually overflow. The value that you pass it is internally multiplied by 1,000. So if you pass it very close to the integer limit, when it gets multiplied by 1,000, it will overflow and you will get a different value, and the program will operate. Instead of taking 25 days, for example, for the delay, it would actually do that in a couple of seconds. So far, so good, right? This is a vulnerability. It's an integer overflow. It was requested like that. And when the guys at the CV registrar saw that, oh, integer overflow, this is really risky, let's slap a 9.8 score to this.
Wow.
9.8, okay? To give you some context, Log4j got a perfect 10. Most OpenSSL vulnerabilities also get in the 9.5, 9.8 range because they are really risky. So immediately, there's the problem of the actual scoring. I'm going to go into details about the specific one in a minute, but there's the problem of the context for this. Just because it's an integer overflow, it got a 9.8. The people doing the scoring, they have no idea of how this operates in the code internally. They can't have. There are too many different code bases out there. They would have to understand all possible values and all possible parameters at all possible moments to be able to have the context for a specific value overflowing. And that's a problem because they are now not scoring the vulnerability, they are scoring the problem, the integer overflow, not the integer overflow in this exact context.
Right.
So still, they requested the vulnerability, it was assigned, it got a 9.8. And where does this get funny? Is that a few days after it was announced, the guys from the curl project, which handle the security problems very well, they are very transparent about the problems that they have and how they are addressed and fixed and which versions, and they come out with all the information that you need to track this. So they came out and they provided some context to this. Apparently, this was a problem that had been submitted to the curl project in 2019, so 4 years ago. At the time, it wasn't deemed even a security problem. It was a bug because the delay wasn't doing the exact time that it was supposed to. But it was a bug, not a security problem. To trick this into happening, on a 32-bit system, you would have to ask for a delay of 25 days, a bit over 25 days. And if it overflew there, it would give the request a retry after a few seconds rather than those 25 days. Hardly a security concern. But it could still be construed if you have enough curls on enough systems doing this and you could trick them into attacking a specific target. You might use this as a denial of service, but at that point, you would be better off using specific denial of service tools rather than this.
Yep.
On a 64-bit system, to get this to overflow, you would have to ask for a retry value that would be larger than the expected lifetime of the universe. So,
wow.
Yeah, very long number.
Trillions of years, if I remember correctly.
So when this was submitted in 2019, the people on the curl project, they didn't consider this a security problem. It was a bug. They fixed it. It was released. The fix was released in 2019. So the CVE that was assigned right now, it was bogus, right? So they got in contact with the registrar. They tried to take it down. They tried to at least get them to revise the score because it wasn't a security vulnerability. And they couldn't do either. So, and this is absurd. The people that are writing the code are explaining this to the people who are assigning the grades, and the scoring and all of that, and trying to get them to change this, and they couldn't. And if this doesn't mean that the system is somewhat broken, then yeah,
it kind of does.
Really paying attention.
I think, and just to give another example of context, I don't know what this one scored, and it's just a funny one that I think we covered or at least mentioned a long time ago, where somebody discovered if you have the grub password prompt when you boot a server and you press enter a certain number of times, it'll skip the password. Now, you could argue that's a very serious issue because that lets somebody into the server, but you could also argue that if they made it past the receptionist, past the IT team, and they made it into the server room in order to do this, you probably have much bigger problems before that vulnerability. So then the context is that, it may not be that big of a deal in practice because the likelihood of someone getting in, and if they did get in, that's your problem, not the fact that somebody is able to bypass a password. You have to also look at, is it likely that somebody could use this vulnerability? Is it unlikely that it could be used, but likely in a, side channel or like a, lateral movement kind of thing? Those are things you think about. But in this case, as you were saying, it got a 9.8 just because it was an integer overflow without the context being in that. And I think that's, absolutely yet another example. And I'll see this constantly where someone needs physical access to break into a server. If they have physical access, they could get a sledgehammer and just bash the server into a million pieces at that point. They don't need a security vulnerability to cause trouble if they make it into your data center. They could just get some shears and start cutting cables, okay? It's not, but these are the things that I feel need to be thought of as when you're dealing with this kind of thing. And just getting a 9.8, I mean, that's going to make curl look like they're one of the worst things ever. But is that going to be a problem? Based on what you said, it doesn't seem like it in practice it would be.
The problem here, one of the problems here, is that when you're dealing with security and patching and updating the stuff that you're running, when you see a 9.8 in curl and you're paying attention, you go into panic mode because curl is everywhere. So you right now are just counting the minutes to get the patch, to deploy the patch, and everything is in panic mode and we're going to get hacked and all of that. And you're not. Your systems are not at risk. You're not going to get hacked, but still there is a 9.8 vulnerability. So what gives? This affects many different things. Most compliance frameworks out there, they will require you to patch vulnerabilities above a certain score within a certain time frame. 9.8 is definitely within those scores.
Yeah.
So you would have to patch this. Okay. The thing is, according to the curl people, there's no version of curl that's vulnerable because it was patched immediately. There's no version currently shipping that has this. The last version where this happened is like 20 or 30 versions ago because they're released often. So it's no longer being shipped like this. It would have to be a very old version to have it, and still it wouldn't be a security problem.
Yep.
Now,
that means Debian doesn't have this problem, surprisingly. Sorry, I had to. Okay, just you send your hate mail. I accept it.
You're not making too many friends on the Debian side.
But I love Debian, though, to be fair.
So another thing with the CVE scoring system is that you have multiple registries for this. There are multiple registries out there at the national level, at the corporate level. Multiple registries have the list of vulnerabilities. When you revise a vulnerability on a given registry, the idea is that it will propagate to the others. That's not exactly how it happens. You have no guarantee that the change on the registry, even if it was the one where it was submitted, will actually reflect on the others within a reasonable time period. It can take months to reflect that, if at all. For example, registries in China might not be very keen on picking up changes on registries in the US, and this has happened in the past. So what happens right now is that some registries are showing this specific vulnerability in curl as being disputed. The score has been lowered from 9.8 to 3 or 4 or something like that. I checked before we started recording. We started recording this, but I'm not exactly sure. But it has been lowered. However, that information is not reflected on all the registries. So if you have a security tool that's running vulnerability checks on your systems, and they see that you have curl deployed, and they see that this vulnerability is a 9.8 on the registry that they are going to get their information, your systems will be flagged as being insecure without any actual risk attached to it. So this is a problem. And this is something that affects basically all the tooling and all the decisions that we have to make when we're prioritizing patching and our maintenance windows and all of that, because this will have to fit into that schedule. Because it was wrongfully scored initially, and that's a problem.
There's probably a lot of unnecessary work, like you were saying. Compliance is that was a very good point, and that literally means there's IT teams out there that are working to patch this, or at least they were, depending on which score they're looking at. To your point, and they might be wasting time fixing this when they could be working on something that's more egregious.
And that's just one side of things, because just as in this case, the scoring was lowered, in other situations, it can be raised. So imagine that you have a vulnerability that initially received a 5, for example. That's not critical. You're not so urgent. There's no pressing need to patch it immediately if you're just doing it according to that score. But say that something else comes out, or a new exploit or a new way to exploit it comes out and is published and is in the internet, and all hell breaks loose. So they revise it, they raise the score, and now it's no longer 5, it's an 8. So you weren't planning to patch it, and now immediately everything goes into disarray because there's a new vulnerability. You must make sure that you receive the patches. You must make sure you allot the time to patch all the systems. You must make sure you know all of the systems where it happens, and you have to address the problem. And this is why the scoring system is important here. And the subjective nature of it and all of these problems that are introduced through wrongly scoring vulnerabilities or not knowing the full context of vulnerabilities and all of that is basically the reason why we are already at version 3.1 of the CVSS system, and we are now going to move into version 4.0, and that will likely not be the last one. For sure it won't be the last one, but
no, it won't be.
There are some concepts that are going to be removed from from this system, and let me just bring up my notes here. Okay, so one of the things that they're going to be doing away with is the scope. Scope used to be something that was published and was considered in the scoring system, and it's no longer going to be, because it's very tricky to determine the scope of a vulnerability. You might have a vulnerability in OpenSSL, but in reality, the vulnerability is present in dozens or hundreds or thousands of different softwares, because they all rely on OpenSSL. So determining the actual scope there, it's very, very difficult. And that's one of the things that they are going to be eliminating, that scope definition, because it's usually not accurate enough for you to do any decision around. They are going to be removing remediation level and report confidence. Those were also factors that were considered. First, because it's really tricky to assign a number value to these things. How do you know if the confidence level of the report is good or not? This vulnerability that I talked about for curl was submitted by someone not even affiliated with the curl project. So what was the confidence that was good enough to assign it a 9.8? Beats me, but it still got the 9.8. And when they tried to reduce it, they weren't considered confident enough. They didn't get enough trust to reduce that. So, yeah. But there are some more changes. And one of the things that I actually like about these new changes is that they are now going to be separating the base score for the vulnerability and the actual threat score. What this means is that you can have a vulnerability that's very risky, that's very dangerous, but has very little ways to be exploited. It's very difficult to exploit, and that will actually lower the score. And having that separate means that you get more transparency into the overall note that is assigned to something like this. And I think that that's a pretty good change here.
Yeah, it is. It seems that way because people need to know, which ones they should be focusing their time on.
Yeah. There is also going to be separation in the information about the consumer risk and the provider risk. What this means is that think about the cloud provider that's offering you hosting for your services. There is different risk for your systems that are running in virtual machines on the cloud than it is for their infrastructure. So a hardware level vulnerability, like the ones that we saw at the end of July and early August, Inception and ZenBlade and all of those, they have a certain risk for the cloud provider, and they have a different risk for the consumer. And that is now going to be separate, and you're going to get information about that on the new grading system. And that's also a good change there.
Yep.
The existence of an exploit is another thing that's going to be changing. Not only is it going to be considered if an exploit is available or not, but how mature that exploit is. Because getting an exploit right now, it's actually easier than it used to be, simply because of the chatbots that can code. But how mature those exploits are, that's something that should also be considered. What they're trying to achieve here is that you might have a way to exploit a given vulnerability that's very convoluted, that takes an enormous amount of different steps and the stars to align perfectly and the planets and all of that to be able to exploit it. Or you can have a one-liner that takes down the system. Those are very different threat levels there, and they are going to be considering that. So one of the things that they have put up with this new proposal is that they have examples of how the grading system will affect existing vulnerabilities, because that's also something that's going to happen. And this is the funny part here. Existing vulnerabilities that already have a grade assigned, that grade will be revised for 4.0. For example, Log4j, which had a perfect 10 here, and we all know the problems that it had, will be slightly reduced given the new grading. On that one, that's not too much of a problem, but there are some stuff that used to have, that previously had like a 6 or something like that are now 8 and 8.3, and those will fall into the categories that we talked before, where you weren't supposed to be patching those to meet compliance, and now you need to patch them to meet compliance.
Right, yep,
So
that makes sense.
that's going to change your operations considerably for the next couple of months. If you're relying on the scoring system to do your planning and to do your operations and your maintenance and all of that, you're going to have to consider vulnerabilities that you might have looked at in the past and weren't going to patch and might now fall on your radar again.
Yeah, and it looks like if I'm looking at this correctly, like the target is October 31st of this year. That's when they're hoping to have all this done.
Yeah, that's the date that they are planning for. They have actually pushed back the date for comments. It was originally the 31st of August. It was moved to the end of September. But the date when this is going to go into effect is October 31st, yes.
Yep. So, which could change. So we'll let you know if it does.
Yeah. But if you're in any way, if your work relates to this or touches on this in any way, you should look at the example list and at least to get an idea of the changes that are coming for the stuff that it's already out there, and to give you some feel for the way that the scoring system is going to be operating now. You will be getting more information. The information will be more detailed. However, it doesn't completely eliminate the subjective nature of some of the scores there. And that's something that we might still get a version 4.1 or a version 5 or something like that. Because as long as there are subjective factors here, and it will always be difficult to score this correctly, we will be hit with some grades that are difficult to explain.
That's, yeah, transition processes are often a little weird. And you got some quirks to get through. But one thing I'm kind of wondering about is when the popular security scanners are going to pick up the new, scores, because I know a lot of people will have tools to scan their systems to report on these kinds of things. And if their solution isn't all that great, it's not caught up, then they won't see any changes. But assuming you're using a good one, then, or I don't know if they all will, I hope they all do, you'll probably see some come back up on the list again.
You're probably going to see something similar to what we are seeing today with the tools in the registries when they are where they are showing two different scores. You are still seeing 3.0 scores and 3.1 scores side by side.
Oh.
They will not always be the same, but you have access to both. So I assume some of those will start showing 3 different scoring systems, if that makes any sense. So it depends on when the tools get the updates, if they are going to get the updates immediately as soon as this is available or not. I expect the good ones to do that. I expect the less good ones to take some time before they start picking up on the changes. But keep in mind that regardless of that, if your vulnerability scanner starts popping out reports saying that your systems are vulnerable, those are the ones that are going to be shown to the auditors. So you might want to make sure that those are using the right grading system and that you're patching for that grading system. So this isn't exactly the end of the story, because the CVSS score is only part of the process that you go through to actually grading and scoring and prioritizing your vulnerabilities and your patching operations and all of that. The Linux distro vendors, for example, they have their own scoring systems. Canonical has theirs, Red Hat has theirs, SUSE has theirs. You'll see these security bulletins, these security advisories coming out about the vulnerability, and they will have different gradings. Those gradings are also subjective. Why is that important? Because those gradings are given by themselves and then affect the level of service that those companies give you. For example, when you have an extended support contract with one of those companies, one of the clauses say that they will provide you with security fixes above a certain threshold. If a vulnerability hits a certain threshold, then you will get the patch within a certain amount of time. But they are the ones scoring them. Their score never reflects exactly the CVSS score. And that's a problem, because you might see a vulnerability that has a CVSS score that's very high, and then they decide to give it a slightly lower value so that it doesn't hit the threshold. They don't put out the patch, and now you don't have a patch to deploy. That's a problem, and that's something that happens.
It really does. Another thing you'll see quite often is when there's a vulnerability reported, and then obviously you're going to check your platform of choice to see what they're doing about it. Because of the nature of Linux, you could have a module in the kernel that one distribution vendor is not shipping, which would mean that if there is a vulnerability in that module, that none of their systems using that are going to be impacted because it doesn't apply. It's not applicable to that distribution. There could be a file system vulnerability, for example, that's making its way out of the kernel because maybe it's deprecated, and it's deprecated in one distribution before another, and then one distribution has a vulnerability and one doesn't. And this is why, or one of the reasons why this exists, but also why you have to take that into account when you're looking at a vulnerability, because it might be one that doesn't apply to you, or applies to you and doesn't apply to someone else. And unfortunately, that's kind of common.
Incredibly common, unfortunately.
Yeah, yeah. I thought there was one with Red Hat. I can't remember which one that didn't impact Red Hat, because I could have sworn there was in the news where they said that they don't ship that in their kernel, so it's not a problem. I just can't remember which vulnerability that was off the top of my head.
I know which one you're talking about. I don't recall the package, but I know another one that's almost in a similar situation. There was a vulnerability that got a 9.8 on OpenSSL. That affects basically all versions of OpenSSL. This was some time ago. It's not something recent. You don't need to rush out to patch. But it affected version 7, RHEL 7, CentOS 7, all of those nice distributions. But the way that the advisory was written on Red Hat site basically came out with, oh, this affects a script that we don't run directly on a default installation, so we are not going to patch this. So instead of 9.8, our score is 4 something. So basically it went from really, really bad, end of the world bad, to, oh, it's slightly bad. We're not going to be too concerned about it. And we're not even supporting these systems anymore, so tough luck getting the patches. The thing there is that they're looking at the default installation. They have no idea if an application that you deploy on the system is actually using that script or not. They're calling that script behind the scenes. You yourself might not know if an application or a website or a tool that signs executables or something like that is calling that script. So the right way to approach that, again, right here, me from my almighty horse here, the right way to approach this would be to patch anything that comes our way that touches our systems. We should have patches for, but they are choosing not to for these reasons. It's only that these reasons are very thin, in my view.
Yep, absolutely. So yeah, there's a lot of context here that needs to be taken into account that clearly isn't.
But yeah, I urge everybody to take a look at the examples that are going to show up. We're going to have the link for this, but if you look, if you Google for CVSS 4.0 examples, you're going to find a page that has a huge list of vulnerabilities. They show you the previous score, they show you the new score under 4.0, and you'll be surprised to see some of the changes there, because they are very drastic. And again, it will reflect on your workflow if you're dealing with patching and maintenance operations. So yeah, it should fall under your radar and you should pay attention to this.
Yep.
I guess that's all for our episode today, unless you have something else.
No, I think that pretty much covers it. And we'll, like you said, we'll have all the links ready when I finish posting this in about an hour or two from record time. So probably will be there by the time you're hearing this. So
thank you, everybody who joined. As always, it was a pleasure. And until the next one.
See you soon.
Bye.